Hello, can you hear
Yes,
me?
sir. Yes.
Okay. So, how much have you done in the problem set that I had shared?
Sir, uh, I tried till 82.
Hmm.
82.
Tell me which questions you have not been able to do.
Mm, Sir, the questions are actually in the question number 63.
Hmm.
I thought no, not in 63, 62. Uh,
Hmm.
we had to prove that 45 upon 4 sine a minus root cos a equals root m plus 2 minus root m minus 2 upon n.
Hmm.
I was able to prove the LHS thing equal to root m plus 2 minus root m, not m minus 2. I was not getting m minus 2 upon n.
Okay, let's start with that 62. The question is saying A belongs to 0 to pi and you have root over 2021 divided by 2 sine A minus cos A equals 1. And you have to prove that cos A is greater than 0 and 45 by 4 sine A minus root of cos A is equal to root of m plus 2 minus root of m minus 2 whole divided by n for some positive integers m and n. Integers m and n which are greater than equal to 2. Okay, so okay. So first of all, the condition that is given, we'll start off from there, and
Hmm.
you can write this as uh, root over 2021 by 2 sine A is equal to 1 plus cos A,
Yes.
and therefore you can write sine A by 1 plus cos A is equal to 2 over root over 2021, right?
Hmm.
And here at this step, converting to half angles will be useful. You can write 2 sine A by 2 cos A by 2, and this can be written as 2 cos square A by 2 minus 1, right?
Yeah.
So you will get denominator 2 cos square A by 2. So basically this expression becomes basically tan A by 2, right?
Hmm.
So tan A by 2 is coming out to be 2 over root over 2021. That's the first step. Okay.
Yes.
Uh, then first thing that you should notice here is 2 over root 2021 is less than 1, right?
Hmm.
Correct.
Yes.
This quantity is less than 1. So A by 2 angle is less than pi by 4, right?
Yes.
Okay. So A angle will be less than pi by 2, right?
Hmm.
Which means cos A is positive.
Hmm.
So part of it is done by just looking at this value, right?
Yes.
Okay. Then
Hmm.
now we have to figure out the rough value of this thing. Then only we can do it. We know this. We have to figure out this, right?
Yes.
Okay. So we have tan A by 2 is given as 2 over root 2021, and we have to find out the value of 45 by 4 sine A minus root cos A. And this is where the standard identities will be very useful. Sine A is 2 tan A by 2 by 1 plus tan square A by 2. Everyone knows this.
Yes.
Similarly, cos A is 1 minus tan square A by 2
1 plus tan square by 2.
by 1 plus tan square A by 2. So sine A value can be easily found. Cos A value can also be found, right? Because we know this. So if you
No.
simplify it, you should get this 4 times root over 2021 divided by 2025 here. And here this should come out to be 2017 by 2025. Right? After that, it's a simple calculation. And if you calculate it, you will get the value as root over 2021 minus root over 2017 divided by 45, which you can see is 2019 plus 2 minus 2019 minus 2. Do you understand what I'm saying?
Yes.
See, it's just a calculation. Maybe you made some calculation mistake, right?
Mm. Mm.
Were you getting something like this?
Actually, no.
Did you get tan A by 2 value of this?
I did that for cos A greater than 0. Then I simplified the first expression. From there, I got 45 sin A as root over 1 plus cos A upon 2. Then I
So
subtracted.
you should just directly find sin A and cos A. No, you are doing
Mm.
unnecessary work, right? You should
Mm.
just directly find it. There is no issue here. You understand what I'm saying?
Yes.
Okay, what is the next doubt? After 62, anyone has any problem somewhere?
Sir, can you wait 1 minute? I'm rejoining from another device.
Fine.
Okay, sir.
सर the problem 66. सर मतलब
Hmm.
ये समझ ही नहीं आया मतलब यहाँ क्वेश्चन जो लिखा हुआ है लिस्ट पॉजिटिव एंगल अल्फा फॉर विच द एक्सप्रेशन हैज ए डिग्री मेजर ऑफ m upon n.
You have to find the angle alpha. Degree measure means finally the answer has to be written in degrees, not in radian.
So what will be m and n?
Some numbers.
Sir,
मतलब
Did you
if
find the
अल्फा
angle
अल्फा
alpha?
अल्फा
sir,
is 45.
sir, I have, sir,
Hmm?
sir, do we have to do like just first in this question 3 by 4 sine square alpha, we will take 3 minus 4 sine square alpha upon 4.
One
Then we
second.
can multiply both up and down by sine alpha, sine alpha.
1 second. This is the equation given. Your job is to find alpha. And somebody is saying you have found also pi by 4, right?
Sir, my one is also coming.
No, you guys are getting wrong answer. You are making some mistake.
91 upon सर ऐसे कुछ आ रहा था 90 और 41 सब.
Ah, so whoever is saying 90 by 41 is correct.
हाँ, yes sir.
Anant, you were saying pi by 4. That's wrong, right?
Sir, it is one of the solution but not the smallest. I also did it today.
Least positive you have to find, no? So let's see what has to be done here. So, okay. So 3 minus 4 sine square alpha is here and divided by 4 is there. And everywhere similar pattern is there, no? Do you understand what I'm saying right now? Right? What can we do here? Does it remind you of some formula?
Yes sir.
What formula?
Sir, if we get 3 sine alpha minus 4 sine cube alpha, we get
Hmm.
sine 3 alpha.
The formula is sine 3 alpha is 3 sine alpha minus 4 sine cube alpha, right? So notice that if I had taken sine alpha common here, so I will get what? Sine 3 alpha by sine alpha is what? Is it this? Is everyone understanding what I'm saying right now?
Yes,
Yes.
sir.
So obviously here I can replace this with what? Notice that all the 4s I can take out 1 by 256, and I can replace this part as sine 3 alpha by sine alpha, right? And I can replace this part as what? Instead of alpha, there is 3 alpha, right?
Yes.
What would it be? Sine 9 alpha by sine 3 alpha.
Yes, sir.
So can you see that it is cancelling nicely? Next one will be sine 27 alpha by sine 9 alpha. And next one will be sine 81 alpha by sine 27 alpha. Is everyone understanding what I'm saying right now?
Yes, sir.
So if you get these, then automatically you are getting nice cancellations and you are ending up with sine 81 alpha by sine alpha, and 256 will get cancelled, is equal to 1, right? Correct. We are getting sine 81 alpha is equal to sine alpha. The solutions of this will be 81 alpha is equal to n pi plus minus 1 power n alpha, right? Correct.
Yes.
So if you think about it, the lowest value will come when you have 81 alpha and alpha are supplementary, right?
Hmm.
Do you understand what I'm saying? When you put n is equal to 1,
Yes.
that is the lowest possible value that you will get. Positive value, otherwise the value is 0 is also a root, right?
Hmm.
So you are getting alpha is coming out to be 82 alpha is coming out to be pi, but we have to write the angle in not in radian, in degrees. So this is 180 degrees. You're getting alpha is equal to 180 degrees by 82. So that is 90 by 41 degrees, right?
Yes, sir.
And the required answer is 131, 90 plus 41. You have to express the answer in terms of degrees, not in radians. But the main idea is to see this thing and be reminded of the sine 3x formula. If you can see the similarity, then you can immediately notice this and take a sine alpha common here, right?
Yes, sir.
Okay, what's the next doubt?
Sir, 73.
64 also.
Okay, 64 first. Let AB belongs to 0 to pi by 2 such that 169 sine A sine B plus 559 sine of A plus B plus 1849 cos A cos B is equal to 2018. And we have to evaluate tan A times tan B. Okay, fine. Numbers look weird, but if you do some prime factorization, you will understand what is happening here. So first of all, you should notice that 43 square is this. Do you realize that? When the numbers are so weird, you should always look at the numbers. What is special about them? Did everybody realize 43 square is 1849?
Yes.
No, sir.
Okay. This is 13 square and this is 43 into 13. Can you see?
Hmm.
So now the hint is there. From that only the hint is there. That, okay, I have sine of A plus B here. This can be expanded into two terms, right? This can be split into two terms. and they have 43 and 13, and here you have 13 square and here you have 43 square. So this is like middle term factorization, right? So what I will do is I will write it like this: 169 sin A sin B plus 559 sin A cos B plus 559 cos A sin B plus 1849 cos A cos B, right?
Yes, sir.
And we can easily factorize it because this is 13. We can take 13 sin A common here, and we'll get 13 sin B plus 43 cos B, right?
Yes, sir.
And here we can take 43 cos A common, correct? Are you seeing what is happening?
Yes, sir.
So it is becoming nice factors: 13 sin A plus 43 cos A times 13 sin B plus 43 cos B, right?
Mm.
And they are saying that it is equal to 2018, right?
Mm.
Okay. So now at this step, you should also think about what is 2018. Perhaps 2018 is also a nice number, something nice is happening there, right?
43 square plus 13 square.
So 1849 plus 169, right? Think
Yes,
about
sir.
it.
20.
It
Yes,
is 2018
2018.
only,
Mm.
right? So 1849 plus 169 or 43 square plus 13 square, right? So now the inequality is becoming equality is becoming something like this. 13 sin A plus 43 cos A multiplied by 13
13
sin B,
sin B plus 43 cos B.
43 cos B is equal to 13 square plus 43 square,
43
right?
square. Yes, sir.
What should I do now? देखो, एक इक्वेशन है, दो अननोन्स है, ऐसा नहीं है कि हम लोग सॉल्व कर सकते हैं डायरेक्टली. देयर हैज टू बी सम ट्रिक, राइट?
Mm.
There is no direct solution possible, so you have to think of something nice. That's why the numbers have been given like this. Whoever has solved this question, what did they do? What did you do? Somebody has solved it. No, Anand has solved
No,
it,
no,
right?
I also forgot. I forgot to ask it. Like
Oh.
Okay.
I moved on from 64 then.
Mm.
I forgot. I also did not know.
So at this stage, what should we do? Think about it, everyone.
Yes, sir. Thinking.
If you look at the pattern, sine and cos are like this, 13 and 43. Here also 13 and 43, right?
Yes, sir.
This is like saying uh, um, 13 sine x plus 43 cos x whole square is equal to 13 square plus 43 square, where x can be a in one time and b another time, right?
Yes, sir.
Like ultimately what is happening? You should realize that it is not like there was a sine of b here and a cos of a here. The pattern is the same, right? Or
Yes,
another
sir.
way
Yes.
to think about it is you can say that this expression this expression will be less than equal to root over 13 square plus 43 square, right?
43 square. Yes, sir.
And so this expression also will be less than equal to root over 13 square plus 43 square, right?
Yes, sir.
So the product has to be less than equal to this. So it is guaranteed that the product has to be less than equal to this, right?
Yes, sir.
Yes.
But we have to have equality for both, right? Then only equation will be satisfied, no?
Yes.
Yes, sir.
It cannot be that one of them was lesser, one of them was equal. Then the equation is not satisfied, right?
Yes.
So both the situations, both the expressions have to reach their maxima value, right?
Yes, sir.
Correct. So how will they reach their maximum value? You can think about it. When does a sin x plus b cos x become equal to root over a square plus b square, right? Correct. So for that, we can write it as root over a square plus b square sine of x plus phi, right?
Yes, sir. Is equal.
Where cos phi was a by and sin phi was b by. So tan phi is b by a, right?
Yes, sir.
Do you understand what I'm saying right now?
Yes.
So the maximum value will happen when x plus phi is equal to pi by 2, right? X should
Yes,
be
sir.
pi by 2 minus phi, correct?
Yes, sir.
So we can say that sin x should be equal to sine of pi by 2 minus phi, so cos phi, right?
Yes, sir.
So the maximum value of this expression happens when sin x is equal to cos phi. What is tan phi? Tan phi is b by a. So what is cos phi? Cos phi is a by root
A
over
by
a
is
square.
square plus b square.
So the maximum value happens when sin x is equal to this, right?
Yes, sir.
Do you understand what I'm saying? So obviously then cos x will be b by this, right? Correct? No. Are you understanding what I'm
Yes.
saying so far?
Yes.
So in this case, maximum value will happen when sin A will be equal to A by, so 13 by root over 2018, right? And cos A would be 43 by root over 2018. Do you understand?
Yes.
Similarly, for
Yes, sir.
B also the same thing should happen. No, sin B should be 13 by this and cos B should be 13 by this, right?
Yes, sir.
So notice that in each case tan A is what? 13 by 43
33 by 43. Yes,
and
sir.
tan B is also 13 by 43, right?
Yes, sir.
So tan A tan B product is 169 by 1849.
Yes.
Okay.
So how are we thinking about it? We're thinking of maxima, minima of these expressions, right?
Yes.
We already know how to do maxima, minima of this type of thing.
Yes.
And when maxima, minima has to happen, you can figure out that sin x should be a by root over this and cos x should be b by root
B by
over
root
this.
over this. Yes,
Then
sir.
only it will become this.
Hmm.
So from there we have gotten that both expressions should have that same property and tan A is coming from there, right? So nice question, because first step you have to figure out that you have to factorize. If you don't factorize, nothing you can do. And 2018 you have to write and you have to realize what is the purpose of those numbers. Those numbers have not been randomly given, right?
Yes.
Okay. What is the next doubt?
73. Right, Anand?
Oh, also 67.
Okay. 67 first.
You did 67, Aniket?
Yes, I did 67.
Okay.
This is the situation.
Hmm.
And like this, we have till root 3 plus
Plus
tan
tan
of
29.
29 degree.
Hmm.
We have to prove that it is 2 power 29.
Yes, sir.
Okay. So, Aniket, you have done it. Then tell us what you have done.
Sir, um, sir, first I did root 3 written as tan 60 or tan pi by 3.
Mhm.
And then I took the first term and the last term and multiplied it.
Which two terms?
First, first I took tan 60 plus tan 1 degree.
Mhm.
Then it came to sine 61 upon cos 61 plus cos 60.
1 second. If you simplify this, you are getting sine 60 cos 60 sine 1 cos 1. So, okay, so it will become sine 61 by cos 60
Cos
cos 1,
60. Yes, sir.
right?
Yes, sir. Then I simplified the last term, tan 60 plus tan 29.
So it will become sine 89 by
On.
cos 60 cos 29.
Yes, sir.
Okay, then what?
And then sir then I multiplied it. And we can do this for second term and second last term also. But I first did this multiplication. Yes, sir.
So you're getting terms like this, and the second last would be like sine 88
Hmm.
by cos 60 cos 28.
Yes, sir.
So now multiplying, what will you notice here?
So multiply first with last. We will get uh, we will get 2 square.
First with last.
Yes.
Okay, you will get cos 60 will become 2 square, and cos 29 will cancel this.
Cancel out and cos 1
Cos
will
1 will
cancel sine
cancel
89.
this.
Yes, sir. And same for second last and second also. And hence it will
So how
continue.
many pairs are coming? Is everything properly paired up?
Yes, sir.
How do you know?
Sir, we have
There are odd
29
number
minus.
of brackets. तुम ध्यान से लास्ट आर्ग्यूमेंट में क्यों छोड़ दे रहे हो बीच का? The only one thing you have to check that everything is properly paired up or not.
Hmm.
You will get 14 pairs and one middle term which will be unpaired.
Hmm.
समझ में आ रहा है मैं क्या बोल रहा हूँ?
Yes, sir.
14 पेयर से 2 पावर 28 आएगा.
Hmm.
You understand what I'm saying?
Yes, sir. फिर एक बचेगा.
There will be 14 such pairs, and then the middle term, the 15th one, so that will be root 3 plus tan 15 degree, right?
Hmm.
It will become sine 75 by cos 60 cos 15. And
Hmm.
notice that cos 15 will cancel
15 sine
this,
75. Yes, sir.
and this will become 2.
So, okay. Now it's completed.
So
देखा
you
है.
can't do everything and then miss out on the last step. If you don't mention this properly, then they will not give you full marks.
Sure. Will notice. And
Is
next week.
everyone understanding what is happening?
Hmm.
It's not difficult. You have to write it like this and then think about what is happening. And many things are cancelling. Cos 60 is giving us 2 square, right?
Yeah.
Okay. Which one is the next one? Question number?
73.
Yeah.
Okay.
So what is the answer for 72?
72, 1 second. It is the inverse trigonometry summation, right?
Yes.
Hmm. So could you explain?
So is it tan inverse n upon n plus 2?
1 second. Let me just find the question. Right. Okay. So 72 first. So you have summation k goes from 0 to n tan inverse of 1 by k square plus k plus 1. This is a standard thing. The point is, you have to first realize there is a formula for tan of a minus b, right?
Yes, sir.
Hmm.
It is tan of a minus tan of b by 1 plus tan a tan b.
Yes, sir.
Yes.
Okay, so this is a standard formula. Now suppose somebody asked you A minus B. What is A minus B angle, right?
Hmm.
You would say it will be tan inverse of this expression, right?
Okay.
Right.
Yes.
This is my thing, correct?
Yes.
Hmm.
Now, if, for example, we call tan A as X and let's call tan B as Y, then we can say X is tan inverse A. No, tan inverse X is A, right?
Yes. A equals
A
to
is tan inverse X
yes.
and B is tan inverse Y, right?
Hmm.
So now A minus B can be written as tan inverse X minus tan inverse Y, right?
Yes.
Is equal to tan inverse of, now I'll replace tan A and tan B as X and Y.
Hmm.
Hmm.
So you are getting this thing.
Yes.
So that is the inverse trigonometry formula. For when you have tan inverse X minus tan inverse Y, it can be written like this, right?
Hmm.
Okay.
Like later you might have to remember it. It's not very big, it's not a big deal. You're taking the normal formula and just converting it, right?
Hmm.
Is
Also
everyone
similar.
understanding what I'm doing?
Yes, sir.
Yes.
So now our job here is to find out the sum of this series.
Yes.
Here, obviously, k values will keep changing, right?
Yes, sir.
Hmm.
So usually, always when you have a summation, one of the main methods is called telescoping series.
Yes.
Telescoping
Okay.
series or method of differences.
Yes.
This is a standard method that you might have seen before. Everyone must have seen if they have done anything in summations. For example, questions like this you might have known.
Ah, yes, sir.
Yes. Yes.
Every time, what we do? We write the numerator as 2 minus
2
1, 3
minus 1.
minus 2, 4
Yeah.
minus 3, right?
Yeah.
The benefit of doing that is that it splits the fraction into two differences, right?
Hmm.
Hmm.
And as soon as you get nice differences, then they start getting cancelled out.
Yes, sir.
Yeah.
Fraction decomposition.
So basically, we are going to write we are going to write this tan inverse, which is a single angle. It is a
Yeah.
single tan inverse. I am going to try to write it like this.
Yes, sir.
If
Yes.
I am able to write it like this, then same term can be split as a difference of two angles, right?
Yes, sir.
Hmm.
And then the summation will be done by telescoping series,
Yes.
Okay.
right?
Yeah.
So how do I convert this into a form where I can do this? Obviously, I have to think of what to do as x minus y and 1 plus xy, right?
Yeah.
And it is
So we
obvious
can,
now because 1 is already there.
yeah, we can take k common and then it will be k plus 1. Then we can write k plus in numerator, we can write k plus 1 minus k.
Hmm. So
Then,
we already have it like this. We can write it as tan inverse k plus 1 minus k divided by 1 plus k plus 1 times k, right?
yes.
So by the formula, now this is going to be tan inverse k plus 1 minus tan inverse k.
Yes.
Yes, sir.
And now I have to do summation from k goes from 0 to n. So when you do each term, now you will see that the pattern is such that it keeps cancelling. So when you put
Hmm.
0, for example, you get tan inverse 1 minus tan inverse 0. This is the first term. Second term is tan inverse 2 minus tan inverse 1, right?
Hmm.
Yes, sir.
And the last term will be tan inverse n plus 1 minus tan inverse n, right?
Yes.
Hmm.
You should see that the first term of anything, like tan inverse 1 here gets cancelled by this,
Then 2.
and tan inverse 2 will get cancelled by the next term's tan inverse 2, right?
Hmm.
This term will be cancelled by the previous term, but this will remain and this will remain,
This will
right?
remain. Yes, sir.
You will have tan inverse n plus 1 minus tan inverse 0, and tan inverse 0 is 0 only. So your answer will be tan inverse n plus 1.
Yes, sir.
Are you understanding what is happening?
Yes.
Yes,
You
sir.
need to understand the inverse formula, how we get inverse formula, and you need to understand the method of telescoping series. And the same thing happens in question 73. So the only difference is that you have a cot inverse, but cot inverse and tan inverse, there is a nice connection. So we have to prove that this is equal to cot inverse of 1 plus 1 by n, right?
Hmm.
So first thing that you should know is that cot inverse of x is equal to tan inverse of 1 by x. Now you need to understand why this has to be true. It's not like something that you have to memorize or anything. So logically think of cot inverse x. Let's say cot inverse x is supposed to be some angle, right?
Yes, sir.
Hmm.
Let's say it is angle A. So obviously x will be equal to cot A, right?
Cot A.
So what is tan A?
1 by cot A.
Tan
Yes.
A is 1 by x, right?
Yes, sir.
So the A angle is what? Tan inverse 1 by x.
Okay,
Hmm.
yeah.
The A angle that
And
I have called as cot inverse
cot
x
inverse x is
can
equals to
also
tan
be
inverse.
written as this.
Yes, sir.
So we are getting this identity, right?
Uh,
So this is becoming tan inverse of 1 by 2k square, right?
yes, sir.
Now what we will do is we'll do the same method. We'll try to do telescoping series on this somehow, right?
Hmm.
There is no other method of summing of inverse trigonometric things. Always you have to think of telescoping series only.
Okay,
So
sir.
our job is to somehow figure out how can we write it as y minus x by 1 plus
1
yx
plus yx. Hmm.
so that we can split it as tan inverse y minus tan inverse x.
Yes, sir.
So let's think of how to split this. So
Sir, एक
Hmm.
मिनट.
2k square.
A minus 1 k square. Okay, yeah, k square is also there.
so first hint is write it as not like this. 2k square is not nice,
Hmm.
but this is much better.
Yes. 2 upon 4 k square.
And notice that in the denominator you always have a 1 plus something, right?
Hmm. Yes, sir.
So let's write it like this 1 plus
4k minus. Oh, oh.
now it's over.
Hmm.
Yes, that identity.
8 plus
Because
6
now
k
we can
square.
write the difference on top as the difference of this and this.
Ah, yes, sir.
Yes.
2k plus 1 minus 2k minus 1 divided by 1 plus 2k
1
plus 1
plus
into
2k
2k
plus 1
minus
into
1.
2k minus 1. Yes, sir.
So this is becoming tan inverse 2k plus 1 minus tan
Minus tan
inverse,
inverse 2k minus 1.
right? So as soon as you get this, now we can do the summation from 1 to n. So when you do the summation, the bigger term of the last one will be left, right? And
Hmm.
the smaller term of the first term, right?
Yes, sir.
So what you'll end up with is tan inverse 2n plus 1 minus the smaller term of the first one. So minus tan inverse 1, right?
Yes, sir.
Yes.
So you can write this as using the same formula that we have used so far. We can write it as tan inverse 2n plus 1 minus 1 by 1 plus 2n plus 1 into 1, right?
Hmm.
Yes.
So this will become tan inverse 2n by 2n plus 2, right?
Hmm.
So
Took
this is
common.
equal to tan inverse n by n plus 1, right?
Yes, sir.
So that is
Yes.
equal to cot inverse
Cot
n
inverse
plus
n
1
plus
by
1
n.
by n.
That's
Which
the
is 1
proof.
plus 1 by n. सर एक बार आप ये समझा दीजिएगा, ये जो ट्रांसफॉर्मेशन किया मतलब जो आपने कन्वर्ट किया
What conversion?
इन द फर्स्ट सेकंड थर्ड स्टेप.
Which step? Tell me.
नहीं सर, जैसे कि tan 1 प्लस के अपॉन 1 माइनस के या कोई भी उसको हम कैसे दो उसमें लिखें tan इनवर्स में. उसका वो फॉर्मूला।
This.
नहीं नहीं, आपने
But he is
क्योंकि
asking for the manipulation you did
हाँ हाँ, मतलब
from
वही टाइम, वही
2
मैंने।
upon 4k square. That thing, I think.
हम्म।
Yeah.
When I have 1 by 2k square, it is difficult to write this. Even if I put 1 plus, it is difficult to split it as a factor नहीं कर पाओगे ना.
हम्म।
So why did I convert this to this? Because you can't make factors of 2k square. You can't have two linear factors, right?
यस सर, यस सर।
If you do 2 by 4k square, however, now there is a possibility because I can split 4k square as a product of two linear k's.
यस सर।
Why did I do 1 plus this? The reason is because in my formula there is a 1 plus xy here.
tan a plus tan a tan b plus 1, यस सर।
No, the formula has tan inverse of x minus y by 1 plus xy, right?
हाँ यस सर।
So if I have just something here, I need a 1 plus something.
इन द फॉर्मूला, यस सर।
So I'm doing
Hmm.
1 plus this. As soon as I
एंड
see
माइनस
this, it is
ए स्क्वायर
obvious.
माइनस बी स्क्वायर, ओके सर।
Hmm. Hmm.
After that, everything fits.
श्योर सर, थैंक यू सर।
What is the next one? That is a problem. Next question that is unsolved.
77. No, 76. 76 first.
Okay. $76 is let A be a real number. That one, right?
यस सर।
Okay, so A belongs to real such that sine cube A plus sine A cos A plus cos cube A is equal to 1 by 27, right?
Yeah.
यस सर।
We have to evaluate sine power 4A plus
कॉस
sine
पावर
A
4
cos A
प्लस कॉस पावर
plus
4 है।
cos power 4A.
हम्म।
Okay, fine. So this is a nice tricky one because I mean this is a nice trick. This type of trick I've seen in coaching classes questions also sometimes, but you have to realize it like because directly there is no very obvious solution for it. Think of, I will give you a hint. I will write it like this. When you get the hint, it was not so hard. This is the way you need to think now.
ओके।
Don't try to do anything else. Just think of what you can do with this equation. Can you do something here? Or can you think of something here? Think of algebra identities.
Yeah.
हम्म। ए क्यूब
A cube plus B cube minus C cube
There is no such identity.
है।
A cube plus B cube minus
minus
C cube
C.
का अगर कोई identity पता है तो मुझे भी बता दो.
No, no.
ए क्यूब प्लस बी क्यूब 1
Minus.
ए माइनस बी माइनस कॉस ए 1 प्लस sin A।
It's a nice one. See, do you know the factorization of A cube plus B cube plus C cube minus 3ABC?
Hmm.
What is it?
A plus B plus C into अच्छा this one, हाँ, plus c square minus ab
माइनस
minus c
ए बी
whole
माइनस बी
square.
से माइनस सी है.
You know this one, right?
यस सर.
Yes.
ये तो सब जगह बुक्स में होगा. Everywhere you would have seen this.
हम्म.
So the main objective of this identity is if a plus b plus c is 0,
देन ए क्यू प्लस बी क्यू प्लस सी क्यूब इज 3 ABC.
right?
यस सर.
Yes.
So the converse is also true. Like if you have a cube plus b cube plus c cube minus 3abc is 0,
हम्म.
you can say from here that a plus b plus c is 0.
0. ओके.
Why? Because this can never be 0.
हम्म.
You
यस
know
सर.
that this can never be 0.
No.
Do you know or do you not know?
Yeah, I know that it cannot be.
Because it is the sum of squares, three squares, right?
हम्म.
Yes.
It can be written as half of this,
A square plus
ए
b
प्लस.
minus c
या.
minus.
right?
यस सर.
Yes.
So if you know that the left hand side is 0, that guarantees that since this can't be 0, this must be 0, right?
हम्म.
Now this situation here is a cube plus b cube plus c cube minus 3abc is 0.
यस सर.
Why? Because this is my x, this is my y, this is my z, which is minus 1 by 3. You have x cube plus y cube plus z cube minus 3xyz.
3 into x into y into z is equals to 0. Yes sir.
Because x is sine A, y is cos A, z is minus 1 by 3. So because it is minus 1 by 3, it becomes plus sine A cos A.
Sin a plus cos a is 1/3.
Is everyone understanding?
Yes
Yes.
sir.
So from here, automatically it follows that x plus y plus z should be 0.
So sin a plus cos a is 1/3.
Sine A plus cos A is coming out to be 1 by 3 now for us.
Yeah.
Okay. Now we have to think ahead what to do now, right?
अब तो सर हो गया सर.
Sine A cos A निकल जाएगा.
स्क्वायर करके.
And then you can convert this also and all, right?
Yeah, then.
There is no issue if you know this.
Yes, yes.
The answer will be 13 by 81. You can check it yourself later. Okay. So this is the identity. You should always remember this identity. Sometimes questions like this are asked. These are tricky questions because nobody thinks of that directly. Because they have put a number like this, they have hidden it, right?
Yes.
It's a nice trick. What is the next doubt?
आगे तो किया नहीं.
Sir, 77.
जिसने किया है वो पूछेगा.
हाँ, 77.
For positive integers n greater than equal to 2, f of n is a function from 0 to pi by 2 to real, and the definition of the function is given. It is nth root of sine power nx plus cos power nx, right?
Yes sir.
f4a is given as
Root
root
7.
7 by 3 for some a belonging to 0 to pi by 2. We have to find out f3. Okay. So basically,
Yes.
one particular value of the function has been given, right? So let's just write f4a. So f4a would be what? Instead of
4
n, we will put 4 sine
Yes.
power 4a plus cos power
cos power 4.
4a. So we have that it is equal to root 7 by 3. Right?
From here we get sine A into cos A as 4.9.
Okay. So basically by squaring and all, you will be able to simplify it a little bit, right? So if you square it, what are we getting? Sine power 4a plus cos power 4a is equal to 49 by 81, right?
Mm.
Yes
And
sir.
from there, I can write it as basically
1 minus 2 sine square
You can write it as 1 minus 2 sine square a cos square a, yeah. So from there I will get it is 49 by 81 and I'll get basically sine square a cos square a, right?
Hmm.
Sine square a cos square is coming as 16 by 81. And then I can write it as sine square a only, right? Or I can just write sine a cos a
Hmm.
as 4 by
4.
9.
Yes, sir.
Yes.
Because all the angles are between pi by 2 and all, so there is no
Yes.
issue
Yes.
in sines and all. So
Hmm.
sine a cos a is 4 by 9 is coming. And from there, okay, so I can find now sine a plus cos a, right?
Yes, sir.
Because sine a plus cos a whole square will be equal to
Is 1
1
plus
plus,
2 sine a cos a.
right, this. So this will be
So
basically 17.
by 9,
So sine a plus cos a
which
is
is
coming out
17
to
by
be
3. Root
root
17 by 3.
17 by 3.
Yes, sir.
ओके सो ये तो आ जाना
हाँ
चाहिए ना, ये क्या है F3A है,
हाँ हाँ।
ये तो
Sir,
तुमको डाउट नहीं होना चाहिए था.
नहीं, वहां से तो आ गया था, फिर यहाँ ये साइन ए कॉस से मैं देख नहीं पाया।
If you know this you should be able to find this, no?
यस यस।
And you just need to find the cube root of sine cube a plus cos cube a, right?
हाँ वो तो फिर।
It is doable from now.
हाँ।
I'm telling you the answer. The answer should come out to be sixth root of 425 divided by 3.
हम्म।
Find the answer yourself. It's not difficult.
yes,
या
sir, sure. Uh, sir, how can we find the value of small r in circle?
Which question?
Sir, in question number 84, it is also there, and 83 also.
So if you
No, sir, I'm just asking how can you find value of small r in radius?
don't know the SL only chapter 12 or chapter 15.
So, it's 15. Sir.
In radius, how do you find? There are many ways to find. If you have a triangle like this, how do you make in center?
By angle bisectors.
So let's make two angle bisectors. Third one will also intersect. This is my in center I, and I can make a circle like this, and the radius of that circle is supposed to be R, right?
Yes, sir.
So there are four formulas that you need to know. One is this, one is this, one is uh,
10a/2 size. Yes.
and another one is A tan B tan C. No, A cos by sine, something like that. I'm forgetting exactly. I'm forgetting right now. I'll have to derive it. Fourth one, I have to derive it. There is a cos by sine
Sine
formula.
sine a/2 cos a/2 some b/2 c/2 something like that. A into sine a/2 something like that it is actually.
It has sine and cos. There are two sines or two coses divided by one opposite ratio.
Yes.
It is A sine B by 2 sine C by 2 by cos A by 2 or something. Oh yeah, this is the formula. All of these four formulas are derived in SL only.
Yeah.
आज जाके कर लूंगा सर अभी derive देख लूंगा.
All of these derivations are there. The easy derivation, easiest one is this. That is obvious because you can see that the triangle is being divided into three parts, right? Now, if you do the area of IBC,
अच्छा,
area
okay.
IBC is what? Half
Half
into
into
R into
2
this.
a.
What is this? This is A. And similarly, area of IAC is half
Half into r
into,
into b.
and
Half
this
into
one.
r into c.
So the sum of the
So,
areas is the
okay, so it
overall
will be
triangle. So it will be half R A plus B
half
plus C.
b. So r
So,
is equals to
so you are getting A plus B plus C by
triangle
2 is
by
S.
area upon semicircle. Okay.
So that is the first formula. The second formula is this one is the second one that you need to derive. So I
Sure,
will show
sir.
you. Let's say this is the situation APC. This is my in center. Now, so from in center I have drawn this. This is R, and let's mark it as D. What we will do is we will understand that this angle is B by 2, right?
Yes, sir.
And this angle is C by
C
2.
by 2.
Yeah.
So let's write down what is BD, right? So we can easily say that R by BD is tan B by 2, right?
Yeah.
Tan B by 2 is R by BD, right?
Yes, sir.
So what is BD?
Uh,
R
R
by
by tan B
tan
by
B
2.
by 2.
B by 2, right?
Uh,
Similarly, what is CD?
CD.
This
Yes.
is obvious, right?
Yeah.
And then we have that A is equal to BD plus CD, right?
Yes, sir.
Yes.
R by tan B by 2 plus R by tan C by 2 should be equal to A, right?
Yes, sir.
So you will take R common and you will have here cos by sine,
Cos.
Yes.
right?
Cos
So it
B
will
by 2.
become
Sine B by 2.
sine of B plus C by 2 on top, and it will be sine, right? Do you understand?
Yes, sir.
And sine of B plus C by 2 is 90 minus A by 2, right?
Yes.
So that is cos A by 2,
Yeah.
right?
Hmm.
Numerator is cos A by 2, denominator is sine, right?
Yes, sir.
So we are getting R is equal to A sine B by 2 sine C by 2 divided by cos A by 2.
The fourth one.
This is
Last
the
one.
fourth formula.
Yeah.
From this, it is obvious how to get the second formula. Second
From
formula is
sine.
obvious by sine rule,
Yes. For 2R sine.
because we can say that in any triangle, A by sine A is B by
B
sine
by
B.
sine B is equal to C by sine C is equal to 2R.
Yes.
So we know that this A is 2 capital R sine A. And therefore
Yes.
it is 4R sine A by 2
4R
cos A
sine
by
A
2.
by. Sir.
Cos A by 2 got cancelled.
A by cos A by 2 becomes basically 4R.
4R sine A by 2.
Sine A by 2.
B by
Sine
2. Sine C by 2.
This is the third formula.
Hmm.
And the last formula is also a very nice formula that depends on properties of circles. So
Okay. Sir,
if you have,
where can we use this formula? How to identify like we have to use this formula?
by knowing how the derivation comes, depends on the question, no?
Depends on what is given in the question.
Depends on the question, depends on whether you know how the formulas have come. अगर कोई फॉर्मूला जस्ट मगअप कर लेगा तो फिर उसको कोई आइडिया नहीं होगा कब क्या यूज करना है। अगर बस 4 फॉर्मूलाज मगअप करके जाओगे तो कभी कोई आइडिया नहीं होगा। लेकिन बिकॉज आई नो हाउ इट हैज बीन डिराइव्ड, नाउ आई नो व्हाट आइडियाज वर यूज्ड इन द डेरिवेशन। अगर प्रॉब्लम आएगा जिसमें उस टाइप का कुछ आइडिया आ रहा है तो वो लगाएंगे। इट डिपेंड्स ऑन द प्रॉब्लम, नो देयर इज नो मैजिक आंसर्स। समझ में आ रहा है मैं क्या बोल रहा हूँ?
Yes, sir.
You will only get that sense if you know all the derivations. Otherwise, you will not get any sense of when to use what. Do you understand what I'm saying?
Yes, sir.
The fourth derivation, the third formula, which was s minus a tan a by 2, that formula depends on properties of circle. Because this circle is like this, we can say that B is a point from where two tangents are drawn.
Yes, sir.
Similarly, A is a
Yes,
point from where tangents are drawn, and C is also such a point.
Yeah.
So obviously length of tangent should be
BF is equals to
equal.
BD, AF is equals to AE, and CE is equals to CD. Yes, sir.
Yes. Yes.
If we call this as X, this is X. If we call this as
Y,
Y, this is Y.
Y, and C, C.
And therefore, we have this situation And now you can see that 2x plus 2y plus 2z is the perimeter, right?
Yes, sir.
Right?
Yes, sir.
So what is x
Hmm.
plus y plus z?
Semi-perimeter.
Semi-perimeter.
Hmm.
Now you can also see that we can see from the diagram only that x plus y is equal to a.
A.
Hmm.
Yes, sir.
Yes.
So what is z?
S
X
minus A.
plus Y. X minus A.
Similarly, y plus z is equal to what?
B.
S
B.
minus B.
So what is x?
S minus B.
Do you understand what I'm saying?
Yes, sir. When
Yes.
Y is S minus
X
C.
plus z
Hmm.
is
C.
c.
So
So
Y is
y
equals to S
is
minus C.
s minus c.
Hmm.
So now that we know what is this portion x, y, and z in terms of the triangle values like s, a, b, c, these are variables in a triangle.
90.
Hmm.
And we have figured out this is how much? S minus b,
S
right?
minus B.
Yeah.
What is this?
S
It
minus
is s
B.
S
minus
minus
a,
C. Sorry.
and this is s minus
S
c.
minus C.
The
Hmm.
pattern is obvious. From B vertex, the tangents are s minus b,
Hmm.
Then from A it is S minus A and then
S minus C and
right?
yes, sir.
Now we can just join it and say this is 90 and this is r, and just say this is s minus b.
So
And we
फिर
can say that this is b by 2,
R
right?
upon S minus B is equals to
yeah.
10 B by 2. हाँ
Hmm.
R is equals to S minus B into 10 B by 2.
This is the fourth version.
Yes.
ये
All the versions are same, but they are coming from different places.
हम्म
The first formula came by area, sum of areas.
Hmm.
The second formula came by BD plus CD is equal to A and writing it as trigonometric ratios.
yes sir.
Yes.
The 4R formula came from the third one only, second one only.
Yes. Second one and
Second
Second one.
one gives two formulas basically.
Yes
yes.
sir.
The idea that BD plus CD is equal to A gives
Hmm.
us two different formulas. And this one
Yeah.
comes from circles and tangents and all,
Yeah.
right?
Hmm.
Now, if you know all these derivations and if you know sine rule and cosine rule, then 83, 82, all of it you can try.
Yes sir. Now I can.
Try till
Yeah.
85. If you haven't tried yet, then try it properly again.
Hmm.
And I will send the next sheet soon.
Yes
I
sir.
tried till 82. Three questions are left.
You have gotten the question 78, 79 and all.
I didn't get the 79.
78?
Yeah.
What is the answer? 78.
Wait 1 second. I got A as I have to sum. सर एक्चुअली मैंने 3A plus B ने find किया A और B.
What is A and B?
A is pi upon 4 and B is 3 pi upon 4.
Okay, that is correct. Okay, try the remaining questions also. You should be able to do it. Not very difficult. These are like one or two of them might be slightly difficult, like the geometry ones, but don't give up without trying properly. Okay.
सर
Every
81
time, huh?
81 में तो बस वही मतलब इसमें दिखाना था कि ए जो AD स्क्वायर इक्वल्स BD इंटू CD तो वहां से फिर एंगल
There
इज
are
90.
many ways to do it, but whatever you've done, if it makes mathematical sense, then it's fine.
यस फिर उस मतलब जो इस एक्सप्रेशन से आया उसको फिर प्रूफ उसको भी फिर प्रूफ कर दिए तो वहां से A इक्वल्स 90.
So don't give up without trying properly. And in the geometry questions, try to draw a rough diagram to get a sense of it. It is not necessary in these questions so much, but get into the habit of drawing a rough diagram if you need to understand.
Yes, sir.
Okay, fine. That's it for now then. We'll continue on Saturday evening.
Thank you, sir.
Thank you.
Bye.